Okay, we're going to do some practice here, and to begin with, let's look at the following reference values. We want to remember what a normal pH is, what a normal partial pressure of carbon dioxide is, what a normal amount of bicarbonate, HCO3 minus is, as well as the partial pressure of oxygen. So these are values that really you should be committing to memory, right? And you don't have to remember the exact range, just kind of remember the midpoint and then know that if something is drastically off from that, that's not ideal. pH around 7.4, pressure of carbon dioxide around 40 millimeters mercury, that's a pressure unit that's important to know. Pressure of oxygen around 90, 80 to 100, and for the bicarbonate, 22 to 26 milliequivalents per liter. I would write these down, practice with these as you do the following questions, and I think that as you continue through a career in healthcare, these will just be committed to memory as you read stats and understand what they're supposed to be. I would commit them to memory now. Okay, let's look at this scenario. So if we have a patient where we see the pH is 7.3, the pressure of carbon dioxide is 50 millimeters mercury, and the HCO3 minus quantity is 24 milliequivalents per liter. What is the reason for this acid-base imbalance? And I would look at this. First of all, look at the pH and determine is that too low or too high. Remember that acidosis versus alkalosis is referring to too high or too low pH. Then let's look at the carbon dioxide and the bicarbonate quantities, right? Which one is out of range? And does that explain the pH difference that we're observing, right? Take a look at this, maybe pause the video here. Remember that HCO3 minus is associated with the kidneys, metabolism. Carbon dioxide is associated with respiration, the lungs. So pause the video, decide which of these it could be, and then we will discuss. All right, hopefully you were able to work through this a little bit. Here, right, the cause is inadequate ventilation, could be pneumonia, asthma, something like that. But the reason for why we're seeing these stats is respiratory acidosis. The pH is too low, so right there we should eliminate alkalosis. Acidosis is what we're looking at. pH is too low here. And if we look at these stats, the bicarbonate is within range. It's the CO2 that is too high. Too much CO2 means too much carbonic acid. Carbon dioxide becomes carbonic acid, and therefore we have respiratory acidosis. Okay, take a look at this one. We have another grouping of stats. What is the cause of the issue here? Take a look, see what you think, and then we will discuss. Okay, breaking this down again, what is the problem with the pH and which of these two will explain that? So here the pH looks to be too high, right? 7.4 is that midpoint, plus or minus 0.05, so 7.48 is too high, so that would be alkalosis. And is the issue here the bicarbonate or the CO2, right? The pressure of the carbon dioxide. And here, right, we have respiratory alkalosis. And this can be caused from anxiety or hyperventilation. When one hyperventilates, they're breathing in and breathing out. And that causes CO2 to be expelled at a greater rate than is baseline. And when that happens, remember CO2 is associated with the acid. CO2 makes carbonic acid. When hyperventilation happens, there's more CO2 being expelled. That ends up dropping the pressure of CO2 and making not enough acid, alkalosis. Okay, one more that we're going to look at here. Take a look at this, pause again, and see if you can come up with an answer. What's the primary imbalance? Start with, is it too acidic or too basic? All right, in this case, we're looking first at the pH. We see that it's too low, right? 7.4 is that midpoint for blood that we want. So we have acidosis, and this, when we observe it, we see that the pressure of the CO2 is actually fine. This is within range. The issue here is the bicarbonate. There's some sort of a metabolic reason for pH being too low, and therefore we would diagnose metabolic acidosis. Knowing what the issue is and where the issue is coming from is really important in healthcare, and this is a good example of how we can apply our knowledge of chemistry to some basic diagnostic practice problems.